This is Jeremy Hung from Hung's Electronics. Going to do a little bit of a different video today than my usual reverse engineering videos or related topics. Today, I wanted to actually talk about some RF stuff that I've been working on recently, and the search for test equipment actually to actually do that work, because as you may know, can't really do any of that kind of RF hardware work without the right tools. Otherwise, you're just going to be designing certain like filters and other RF components blindly, and you're just going to waste a bunch of time and effort and lots of frustrating moments, which could be fun when you're debugging and stuff. But I'd rather just have stuff working in hand and also just making sure it works. And didn't feel like too inclined to borrow stuff from my consulting clients and other places that actually have these kinds of instruments. So I've been trying to build a lab here with the proper equipment. So this all started, as you can see here, with this HP 8562A. This is not my eBay listing that I bought it from. I actually bought mine from Hamvention for $500. And yeah, these go upwards of, I mean, absolutely above $1,000. So at the time, I actually didn't even know how much it was, but I just knew that, oh, 22 gigahertz. And it has GPIB in the back. Oh, I'm definitely going to buy this and pick it up and take it home with me. Yeah. And play around with it. And yeah, so I've had that here for 2 years. Really haven't done much with it in terms of like actually using it to design with. It's more or less just verifying, oh, my antenna transmits well or it works. Or in the case of with Wi-Fi antennas, oh crap, why is this signal showing up like 20 or 30 dB lower? Oh, that's right, it's because I'm using an RPSMA cable on this Wi-Fi antenna and basically created a cap in line there. So uh, fun moments like that where I'm like, oh, yeah, just duh. But anyways, so with that in mind, ever since then, I've actually been trying to find a vector network analyzer, and as everyone knows, the Nano VNA, which I've actually recommended in even my feature in the new ham radio or the ARRL magazine on the air, is a great VNA for the price. I mean, I absolutely think everyone should have one that's in ham radio that's planning on working and tuning their equipment, antennas and filters and whatever on a daily basis. It's just an absolutely indispensable tool. I mean, and of course, the software, all open source, as well as the Windows software that you need to run it and extract the S parameter data, and have the really nice plots that you can save for your own documentation and stuff. But no, I've been, since I do this as my job, consulting and other things I do, and also at home, as well as, ham radio and stuff, I've been looking at something more serious, and I'll get into this a little bit later, but something that I like to call the S-band gap, which is actually finally, well, the newer Nano VNA kind of breached halfway through it, but again, I think as I keep seeing more and more with hobbyist electronics, a lot of stuff starts to stop around like 2.4, 2.5, which makes sense because that's where all the Wi-Fi stuff is. But then you're talking about you need to have tools and software to design and simulate and verify stuff above 2.5 gigahertz, which is a different beast in itself, because there's a point where the components aren't your standard surface mount components anymore. And yeah, you could buy stuff out of mini circuits or whatever, but if you need to design something very custom for a consulting client like I do, you have to start using like all sorts of like different coplanar waveguide stuff, as well as onboard PCB filters, all those coupled traces and stuff. Because when you're dealing with values that are like in the femto, or like very 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 small, that components don't exist on DigiKey, you need a the right software, which fortunately there's a quite universal circuit simulator, as well as some stuff in KiCad, and I mean numerous open source like Python calculators and stuff, and of course open literature. But yeah, I mean, it all starts with actually getting a VNA to play around with this stuff and verify it. So one thing that I actually still bought anyway was the 8753C, which the 8753 is something I've heard on the amp hour as a very capable vector network analyzer, and as long as you get like with the time domain analysis and stuff. But as like with anything from this era, I mean, it's already been all cracked. So I'm probably gonna look into more of that to enable the harmonic analysis and whatever. Because I mean, why not? So yeah, this one's a 6 gigahertz, which has been my target for a while, and yeah, one of my clients has one of these, and for a while I've been looking at them, and they're all like 3,500 and above, and this one from BRL Test on eBay, selling for just a little under 2,500, and finally pulled the trigger on that. But before I go into that even, I was feeling a little bit more ambitious before this and thought, okay, there's the 8510 series, which, okay, looked into that. It's a huge rack mount system, quite a boat anchor. This is actually the pre-flight check document, which, this is what you use as a quick reference to set up your 8510 system and make sure all your GPIB, or excuse me, HPIB addresses are all set so that everything communicates and syncs up, and actually the VNA will actually work. So this is from the era where the VNA was actually split into 4 different parts, which is the display, the I think the actual like IF detector and stuff, and some of the more RF guts here, and controls actually, and then the S parameter test set, which was actually a discrete unit in itself. And I actually got this the other day. It's like 45 pounds. It's a boat anchor. And then then you have to get the special cable, which you see I bought here. Yeah, as you can see, I paid a lot in shipping with these kinds of things, but I mean, that's the price you pay for that. But as you can see, so far the total is well under $1,000 at this point. And the one thing I didn't realize, because the documentation is kind of sparse-ish and kind of unclear at times, until I read this document, the pre-flight checkout, I didn't realize that the actual signal source was also a discrete unit. And so when I had all this other stuff on order, I was like, oh crap, I need to buy a signal source. And yeah, so the 8360 series, or was it? No, actually, I think it's like the bigger one. I don't remember off the top of my head, but some of those units by themselves are like $6,000, and I was like, okay, we're not gonna do that. So I ended up opting for a 8350B series of RF source that sweeps between 10 to 20 gigahertz, which is actually well within the range. Actually, let me make sure that that's what it was. I think it's 20 gigahertz. Yeah, it's either 20 or 22, but the key point being that it covers the range of the S parameter test set, and that feeds into a dedicated RF sweep port. And how all that's controlled is by that display unit and this unit underneath it as well. So yeah, and I mean, this thing, looking at it, is huge. I even posted on Twitter the other day the Nano VNA versus the S parameter test set, and yeah, that's a quite interesting comparison. Definitely an apples to oranges comparison, because this thing goes to 20 gig versus the Nano VNA being 1.5. But I mean, it just kind of just shows how far we've gotten. So oh yeah, it's just the same spectrum analyzer. Yeah, so I bought all that for about $1,500. But yeah, then because a lot of these were sold as for parts or for not working, which I of course read in depth, because I don't want to just put in a bunch of work. As you can see, this one was sold for a low price because the display goes in and out. Okay, challenge accepted. And fortunately, most of these aren't the most expensive part, and I was probably planning on buying an 8510C so that I could get the LCD upgrade kit for it, so that I have a better display. So I don't know, people might think that's foolish, but whatever. I have the cash to make that work, and love kind of playing around with this hardware. But yeah, so got that, got the cable. Got a bunch of other nice coax cable to go along with it to, fit it all out. And so, yeah, because I didn't think this was gonna work out 100%. My backup plan was to buy this thing, and I did. It's all on the way now. And this is probably going to be my actual workhorse. And so, yep, it has a nice color display, CRT. Thinking about getting the LCD upgrade kit, but yeah, most importantly, option 6 gigahertz and time domain, so you can measure cables and all sorts of other things. But yeah, anyways, this is going to go into a little bit more of a rant now, or kind of like my observations on VNAs and other kinds of RF test equipment. So, actually, this is like 2 years in the making of just like sheer frustration and banging my head against the wall of like, oh, I need this VNA that goes up to 6 gigahertz so I can start playing around with some more serious things into midway through into C-band. Yeah, that's been quite frustrating. As you can see, actually, here's a listing of one of those 8510Cs that's a complete unit. And yeah, this one goes up to 50 gigahertz. And let me tell you, these things, they retain their value quite well, even after like 30 years or so. But yeah, this was back in the day when, these were all separate units before they were all integrated. But the performance is still very, very good. It's like, 100, 110 dB of dynamic range. I mean, there's just nothing quite like that now. That is remotely entry level. So even the Nano VNA, it's amazing because even where I work, basically they use Copper Mountain VNAs, and those things have 110 to 120 dB of dynamic range, and I mean, you pay for it. It's like 13K to 20K depending on the frequency that you want. And I even looked at getting one, but again, the price point's still a little too high. And I figured, since I didn't have that much of a high expectation of the 8510 working, but if I did get it to work, I might try to sell this as a complete system after refurbing it. Maybe even put some money into calling it out, calibration, spending the money for it. Maybe undercut this so that someone else working on more cutting edge research like me can actually use it. So anyway, yeah, so going into more of my rant, I talk about this observation that I've had for a while, the S-band gap, which is beyond your 2.4 gigahertz and beyond your L-band GPS kind of stuff, which is what a lot of the hobby community works on, as well as all sorts of things there, LNAs and other stuff that you can find on Tindy. I actually time to time look at some more of the higher frequency stuff, and I noticed that there's always stuff lacking beyond 2.5. You might find some stuff around 5 gigahertz for other Wi-Fi stuff, but no, it's very lacking, and I always figured that it's because the test equipment beyond that frequency, midway through S-band, it goes up like, another 10 dB, yeah, it's like, thousands to $10,000 of range, so 10 to 100, or no, 10 to 20 dB, right? So, thinking about that, I'm like, okay, so I guess I better wait, I guess, and save up to get one of these. But fortunately, there are multiple options here to finally get a VNA. Anyways, yeah, so even in one of my articles that I contributed to last year, I talk about there's also the fact that everything in terms of just like hobby and consumer stuff kind of stops at 6 gigahertz. Because again, that's where you get another 10 to 20 dB of a price jump in the sheer amount of tests, just for like the test equipment and also just the equipment in general that you're buying. Because it's no hobbyist can afford that at that point. You better start a company and gain a lot of capital before you even think about that. And I mean, even thinking about automotive radar systems, I mean, that's even out of the reach of a typical hobbyist to even start with. And because, again, the gate is at 6 gigahertz as far as with a lot of this test equipment. Because again, so far the setup behind me, conservatively speaking, has I want to say maybe 4 grand, 5 grand so far in it with that VNA now. So it's not horrible because I mean I do this as a hobby and a job, so I reinvest back into it. I love it, so it's my life. But anyways, yeah, that's something I have observed. I would love to see more stuff beyond 2.5 gigahertz, or beyond the S-band gap for hobbyists, and then of course the next stretch goal, so to speak, is going to 6 gigahertz and beyond. Because yeah, I mean, it'd be nice to see more eyes on that in the open source space or the hobbyist community. Because yeah, it's kind of frustrating to see, it's a little disheartening and demotivating to see that, wow, everything just gets expensive and that's just the way it is. Again, if there is a cheap way to get into that research area, or just work in that space at home, I want to know now. Because like I just want to play around with that stuff, as well as of course do more consulting work. Because again, it's a cycle for me. It's like I want to work in it full time as well as play around with it full time. So let me know down in the let me know down in the comments if there is such a thing, or if you can point me to some leads or links. Would love to know. Because yeah, I honestly think I think we're closer to bridging the gap, but it's, I'd say, at least a year or two out, especially now that the 3 gigahertz nano VNA is out, which I still have on order and it's stuck in customs. But fortunately this thing will arrive and I'll have to lift it to my car and bring it here. Can't wait. Fortunately I've been lifting. Well, anyways, on that note, everyone have a nice Memorial Day weekend in the United States, and happy hacking.